Our third example on kinetic theory of gases says, calculate the mean translational kinetic energy of 1 mole of hydrogen at STP. Take the density of hydrogen at STP to be 0.09 kilogram per meters cube. Okay, so we are to solve for the translational kinetic energy of 1 mole of hydrogen at STP at standard temperature and pressure. That's the meaning of the term STP. And we are being given the density of hydrogen gas to be 0.09. So we are going to list the quantities given. Solution. Density is given. Now at STP, we know that volume, pressure, and temperature is a constant. Okay, so at STP, we have the following. The pressure is 1.01 times 10 to the power 5 Pascal. And then the volume is 22.4 times 10 to the power minus 3 in meters cube, or 22.4 in liters. So when you are converting it from liters to meters cube, then we have 22.4 times 10 to the power minus 3 meters cube, which is the value that we are going to use. So in a situation where the value is written in liters, we have to convert it to meters cube. Alright, so the next thing we are going to do is to look for a suitable expression. And these are expressions to help find the kinetic energy. I have mv squared, 3/2 kt, 3/2 RT over NA. I hope you still remember the meaning of the quantities. The m here, small m, represents the mass of the hydrogen gas, the velocity, small v, and k represents the Boltzmann constant, T represents the temperature, then the R here represents the universal molecular gas constant, T here temperature, and Na here represents the Avogadro's number. Okay, so from these three expressions, we have to pick one that will enable us to solve the problem. But when we come back here, we see that from the equation, we are being given density. And at STP, we will have density, pressure, and volume. Density, pressure, and volume. As a student, you will come back and check the expression. We don't have density here. We don't have pressure. And we don't have volume. So we still have to think. We have to be creative to come up with a suitable expression. And we can't say that the expression that we have here is not proper or is not correct. So we have to still go back. But in our first example, if you can recall that we used this expression, equation 1, to solve the root mean square velocity. Okay, so you now see that with the help of this equation 1, we would be able to estimate velocity of the gas as well. So looking at that, it means we should go with this first expression. If this one can give us the velocity, because we have the pressure and the density from the equation. Look at density here and the pressure. We still have to think whether we can come up with the mass, but remember they gave us density, and then density is equals to mass over volume. Okay, so this expression here, we are being given the density 0.09 and the volume at STP is known. So with these two quantities, we should be able to make m the subject and deduce the value for the mass. So it's suitable, we would choose this first expression and have mv squared for kinetic energy. Alright, so let's substitute the given values for equation 1 and 3, then we should solve for the velocity as well. So we can now find the kinetic energy. Okay, so V equals to root 3p all over rho. What is P and what is rho? Substitute 1.01 times 10 to the power 5 for P and 0.09 for the density. When we simplify this and then we find the square root, we will have 1.84 times 10 to the power 3 meters per second square. So we are also going to use equation 3 for the density. Rho equals to mass over volume, making m the subject of the expression. By cross multiplying, we will have m equals to rho v. Now we are going to substitute the value of the density in volume and then multiply both of them. Okay, we have 2 times 10 to the power minus 3 in kilograms. So we have been able to solve for the mass and the velocity. Now we are going to now pick this expression, substitute those two quantities and get the translational kinetic energy. Okay, so look at it there. I have m is given here, look at it here, 2.0 times 10 to the power minus 3, and the v is obtained here, 1.84 times 10 to the power 3. I'm going to substitute that into v, and then look at, we have v squared, so after substituting we will square the value. Okay, look at it there. So E, when we simplify that, we get 3385.6 joules of energy, or we can write it as 3.39 times 10 to the power 3 joules when we decide to write in standard form. 1, 2, 3. Moving this 1, 2, 3 places, we have this in standard form. Of course, 10 to the power 3 means kilo. So in case we decide to write it this way, it's not wrong as well. So don't be confused about that. Okay, so I think we have come to the end of today's class. Thank you for watching, and I am really pleased that you were part of our lectures today. If you have subscribed to this channel, I still say thank you. If you are yet to subscribe to this channel, I plead, go to the subscribe button and click on it. I would really appreciate it. Thank you for watching. See you in our next class. Bye.